Generating cinematic video with high-parameter AI models requires heavy computational brute force. When processing billions of parameters to calculate physics, lighting, and motion, the sheer scale of the math can break the system. Every developer knows the frustration. You spend hours meticulously tuning a complex network of logic nodes, only to have the entire process stall out with a CUDA out-of-memory error. Your graphics card simply ran out of space to hold the data. While that error message sits on the screen, expensive remote GPU farms are locked up and sitting idle. You're paying for dead server time while waiting for someone to manually fix the crash. To stop that financial drain, production pipelines need a reliable staging ground. They need a system capable of intercepting, validating, and testing these heavy operations locally before sending them to the remote cloud. That pre-flight validation is handled by the Maison Volts Pipeline Control Suite. This operates as a unified mission control layer, specifically designed to test and stage heavy payloads locally. By acting as a strict local inspection ground, Maison Volts prevents resource drain before the payload ever reaches the expensive hardware. To execute these payloads across different hardware profiles without rewriting the core pipeline, Maison Volts routes tasks through a modular control deck equipped with 3 hot-swappable switches. Switch number 1 is the Google Colab NVMe queue. This acts as the raw, persistent staging environment for the payload. This relies on a fuse file system, mounting cloud storage buckets directly into the kernel layer. Massive multi-gigabyte safe tensors then stream directly to high-speed scratch disks. It's a zero-copy process from the workflow's perspective, removing the need for explicit downloads. Switch number 2 is the Hugging Face Zero GPU Space Engine. Instead of paying for dedicated servers that run 24/7, this switch dynamically allocates A100 or H100 graphics slices strictly on demand. Switch number 3 is the Direct Inference API Workspace. This bypasses the full node graphs entirely, letting the web interface request near-instant visual feedback and texture generations directly in the browser. This 3-switch architecture allows the pipeline to match the exact required compute power to the payload's specific needs, eliminating wasted server uptime. Execution is where traditional pipelines fail. A single unescaped text string or a mismatched tensor shape is all it takes to crash the run. Instead of letting that minor error crash loop the entire queue, the system triggers Pillar 3, the self-healing payload architecture. The system intercepts the directed acyclic graph, the structural map of the nodes. This broken graph data is sent directly to the Gemini AI. Gemini identifies the mismatch, patches the JSON code in memory, and dynamically resubmits the corrected payload. Because the code automatically patches itself mid-flight with zero manual intervention, developers no longer have to spend their time babysitting fragile rendering queues. A successful, completed render is only half the journey. The true value lies in how the system learns from the payload's completed flight. This brings us to Pillar 4, the consolidated knowledge loop, where the engineering execution data feeds right back into the creative setup. Every executed prompt, frame metadata key, and system trace is automatically organized into clean, markdown formatted scene bibles, creating a readable log of the engineering performance. That consolidated document is then immediately ingested right back into Notebook LM, serving as the active, continuously updated memory for the system. This continuous ingestion creates a closed-loop context vector. It gives the AI assistant a precise historical understanding of the hardware settings, camera angles, and rendering constraints that produced the previous scene. Armed with that localized memory, the AI assistant generates scripts and node parameters that inherently respect the technical boundaries and creative successes of the preceding shots. Maison Volts operates as a self-healing, self-improving cinematic factory, optimizing its own configuration with every shot it creates.